Picture this. Somewhere past the orbit of Neptune, a spacecraft the size of a small car is drifting through total darkness, so far from the sun that sunlight itself is just a faint memory of warmth. Its name is Voyager 1. For almost 50 years, it has been carrying a message, a golden record, humanity's own attempt to say hello to whoever might be listening. And right now, tonight, while you watch this, it is still moving, still calling out into the silence, and nobody has ever answered back. And if you want to be here when that silence finally breaks, if you want to know the moment NASA changes the answer, stick around and hit subscribe, because this channel exists for exactly that moment. Now imagine, just for a second, that someone is out there, not a monster, not a movie villain, just a mind somewhere across the galaxy, curious the way we are curious, pointing something like a telescope back at us. What would they see? A small, wet, rocky planet circling an ordinary yellow star in an ordinary arm of an ordinary galaxy. Nothing special at first glance. And yet, for the last 100 years, this tiny planet has been doing something strange. It has been listening. It has been building machines and pointing them at the sky, asking the same question over and over in 100 different ways. Is there anyone else? That question is about to get closer to an answer than it has ever been before. Not from science fiction, not from a leaked video or a blurry photo, from real telescopes, real chemistry, and real NASA scientists quietly finding things in the data that were not supposed to be there. This is the story of how we got here, what NASA is actually looking at right now, and why the next announcement, whenever it comes, might be the one that changes everything. Let us pull back now and start where most people think this story starts, because most people believe something that turns out to be only half true. Most people think that finding alien life would come down to one single dramatic moment, a signal, a flashing light in the sky. A message beamed at us on purpose, the way it happens in the movies, arriving all at once, undeniable, impossible to argue with. That belief has shaped almost everything we imagine about this search. But the real story, the one actually unfolding in NASA's labs and observatories right now, is stranger, slower, and in some ways far more exciting than a single signal ever could be. To understand why, we have to go back to a moment in 1960 in a quiet field in West Virginia, where a young astronomer named Frank Drake pointed a radio telescope at two nearby stars and simply listened. He heard nothing. Static. The hiss of the universe. But that failed experiment, called Project Ozma, planted a seed that never stopped growing. Drake later wrote down a now famous equation, a way of estimating how many communicating civilizations might exist in our galaxy. It was not a real answer. It was a way of organizing the questions. How many stars? How many planets? How many of those planets could support life? How many of those would ever develop a civilization capable of reaching out? For decades, we could not answer a single piece of that equation with any confidence, because we did not even know if other stars had planets at all. We assumed they probably did, the same way you assume your neighbor's house has a kitchen, but assuming is not the same as seeing. That changed slowly, then suddenly. In 1995, two Swiss astronomers, Michel Mayor and Didier Queloz, found the first confirmed planet orbiting a sun-like star outside our solar system. It was a scorched, gassy world, nothing like Earth, but it proved the idea was real. Other stars had families of planets just like ours. Then came NASA's Kepler Space Telescope, launched in 2009, which stared at one small patch of sky for years, watching for the tiny repeating dimming that happens when a planet passes in front of its star. By the time Kepler finished its mission, it had helped confirm thousands of new worlds. Suddenly, the galaxy did not feel empty. It felt crowded in the best possible way. Somewhere in that crowd, scientists began hunting for a very specific kind of planet, not too close to its star, or the water boils away, not too far, or it freezes solid. Right in that narrow, comfortable middle zone, often called the habitable zone, sometimes nicknamed the Goldilocks zone, because conditions there are not too hot and not too cold, just right for liquid water to exist on the surface. And liquid water matters, because on Earth, everywhere we find liquid water, we find life. In boiling hot springs, in freezing Arctic ice, in total darkness at the bottom of the ocean, water seems to be the one ingredient life on our planet has never learned to live without. So the search for other worlds slowly became a search for other oceans, rocky planets sitting in that narrow warm zone, around stars scattered across the galaxy, each one a candidate, each one a quiet possibility. By the early 2020s, scientists had confirmed more than 5,000 exoplanets, and they suspected there were billions more waiting to be found, most of them too small or too faint for our current telescopes to see clearly. And here is the part almost nobody outside the science world fully appreciates. Finding a planet is not the hard part anymore. The hard part, the part NASA has been quietly working on, is figuring out what that planet's air is actually made of, from trillions of miles away, without ever sending a spacecraft there. That is where the story was sitting for most people as recently as a few years ago. Thousands of planets found, a handful in the right zone. No way to actually check any of them up close. The prevailing belief settled in comfortably. We can find planets, people assumed, but truly checking one for signs of life is decades away. Maybe even a fantasy for our grandchildren's generation, not for us. But that picture was about to change, faster than almost anyone expected. Because in December of 2021, NASA launched something different. Not a planet hunter, an atmosphere reader. The James Webb Space Telescope, built to catch faint traces of starlight passing through a distant planet's air, and split that light apart to reveal exactly which molecules are floating in it. If you have ever felt that flicker of realizing you understood something you thought was way over your head, write it in the comments below, because that same flicker is about to happen again in this video, and it genuinely helps this channel know what to explain next. What Webb found, starting almost immediately, turned the quiet, patient search for other worlds into something that felt, for the first time, like it was actually moving. In 2023, a team led by astronomer Niku Madhusudan at the University of Cambridge pointed Webb at a planet called K2-18b, sitting about 120 light-years away in the habitable zone of a small red star. Nobody expected much. K2-18b is roughly 8 times the mass of Earth, a strange in-between world scientists call a sub-Neptune, too big to be a simple rocky planet, too small to be a true gas giant. What Webb found in its atmosphere was methane and carbon dioxide, both consistent with an ocean world wrapped in a thick hydrogen blanket, a type of planet some scientists now call a Hycean world, short for hydrogen and ocean. Then, months later, came the detail that made headlines everywhere. A possible trace of a molecule called dimethyl sulfide. On Earth, this molecule is made almost exclusively by living things, mostly marine algae, breathing it out into our oceans and atmosphere the same way we exhale carbon dioxide. Here is where the honest part of this story has to come in, because that is what makes it trustworthy instead of just exciting. Madhusudan's team was careful, almost cautious, in how they described it. The signal was faint. Other scientists, including teams that reanalyzed the same Webb data, pushed back hard, arguing the detection was not strong enough to be called a real discovery yet, and that it could be explained by chemistry with no life involved at all. That disagreement is still playing out in journals and conferences as scientists compare notes and argue over the data. And that disagreement is not a failure of the science. It is exactly how real discoveries are supposed to be tested, argued over, and either confirmed or ruled out, instead of simply believed on the first look. While that debate continued around K2-18b, out at the edge of our own solar system, a very different kind of clue was quietly building, one that had nothing to do with distant starlight at all. In October of 2024, NASA launched a spacecraft called Europa Clipper, aimed at one of Jupiter's moons, a frozen cracked world called Europa, wrapped in an icy shell that scientists believe hides a liquid ocean underneath, warmed not by sunlight, which barely reaches that far, but by the constant squeezing and stretching of Jupiter's gravity. That ocean, sealed away under miles of ice, may contain more liquid water than every ocean on Earth combined. And Europa is not alone in that club. Around Saturn, a small moon called Enceladus was found by the Cassini spacecraft to be shooting geysers of water vapor and ice straight out into space through cracks in its icy crust. Geysers loaded with salts and organic molecules, the same basic carbon-based building blocks life on Earth is made from. For a moment, step back down to something small and familiar. Think about the last time you stood at the edge of an ocean, salt air on your face, and felt how alive it seemed, waves moving, birds calling, the whole system breathing around you. Now imagine that same restless, salty energy sealed away in permanent darkness, under miles of solid ice, on a moon smaller than our own, silently doing the same thing, undisturbed for billions of years. That is the scale this search actually operates on. Not one planet, not one method. A whole overlapping web of moons, planets, chemicals, and machines, each one adding a small piece to a much bigger picture. In parallel with all of this, NASA's robotic rover Curiosity, crawling across the red dust of Mars since 2012, has repeatedly detected small, mysterious puffs of methane gas rising from the Martian ground, then disappearing again with the seasons. On Earth, methane usually comes from one of two places, either from living organisms, like the bacteria in a cow's stomach, or from certain kinds of geological chemistry happening underground. Which one is it on Mars? Scientists genuinely do not know yet, and that uncertainty is exactly why the rover keeps sniffing the same patch of sky year after year, refusing to let the question go unanswered. Soon after the K2-18b results made headlines, something quieter but arguably just as important happened inside NASA itself. In 2023, NASA released a public report from an independent team studying what it calls unidentified anomalous phenomena. Unexplained sightings in the sky, and the agency's conclusion was refreshingly unglamorous. Most sightings have ordinary explanations, but a small number remain genuinely unresolved, And NASA committed publicly to studying them with the same rigor it applies to any other scientific mystery, rather than dismissing them or hyping them. That single choice to treat a strange sighting exactly the same way you would treat a strange chemical signal from a distant planet tells you something about how this search actually works. It is not about believing the most exciting explanation. It is about refusing to look away from an unanswered question, no matter how small or how strange it seems at first. By 2025, all of these threads, the exoplanets, the ocean moons, the Martian methane, the atmospheric chemistry, had started weaving into something NASA now treats as one connected science, called astrobiology, and its implications reach further than most people realize. And here is where this stops being about one planet, or one moon, or one strange chemical, and starts being about something bigger, about what it would actually mean for every person alive today if the next piece of evidence turns out to be real. If you know someone who thinks this topic is just science fiction, someone a little skeptical, a coworker, a parent, a friend who rolls their eyes at anything space-related, send them this video, because this is the version of the story built entirely out of real telescopes and real data, not speculation. Because here is the honest truth sitting underneath all of this research. NASA has never promised, and will never promise, a single dramatic press conference where someone stands at a podium and announces, definitively, we have found aliens. That is not how real science works, and any announcement that sounds like that should make you more suspicious, not less. What NASA has built instead is something slower, and in a strange way, more trustworthy. A layered, careful process where each new piece of evidence gets checked, argued over, and tested again before anyone is allowed to call it real. The next major step in that process is already being planned. The James Webb Space Telescope is expected to keep collecting more atmospheric data on K2-18b, and a growing list of similar planets through the late 2020s, adding more observations to either strengthen or weaken that first faint signal, the kind of patient, repeatable checking that turns maybe into a genuine discovery. Further out, NASA and its partners are developing an even more ambitious instrument called the Habitable Worlds Observatory, a telescope specifically designed to directly image Earth-sized rocky planets around sun-like stars and analyze their atmospheres in detail, something no telescope has ever fully done before. It was recommended as the top priority, large mission by the 2020 Astronomy and Astrophysics Decadal Survey, the report that guides where NASA aims its biggest resources for the next 10 years, and current planning points toward a launch sometime in the 2040s. That means the child watching a meteor shower in their backyard tonight could grow up to see the actual first confirmed image of another Earth. Not a blurry dot, not a simulation, an actual picture of a planet that might have oceans, weather, maybe even life, sitting quietly around a star we can already point to in tonight's sky. Closer to home, Europa Clipper is expected to arrive at Jupiter in 2030, after a journey of roughly 6 years, and begin dozens of careful flybys of that icy moon, using radar to peer through the ice itself, searching for the telltale signature of liquid water underneath, and studying the chemistry of that hidden ocean in more detail than any mission ever has before. According to Kurt Niebuhr, a NASA program scientist who has worked on Europa research for years, the mission is not designed to detect life directly, but to determine whether Europa has the ingredients life would need, the water, the chemistry, and the energy. Everything except direct proof itself. So think about what that actually means. We are not waiting for one single announcement. We are waiting for a whole series of them, small ones, technical ones, arriving out of order from different missions, in different years, each one slightly strengthening or slightly weakening the picture. The same patient way a detective builds a case, clue by clue, instead of getting one confession that solves everything at once. The next time NASA holds a press conference about an exoplanet's atmosphere or a strange methane reading on Mars or a new detail from Europa's ice, that is what you are actually watching. Not a final answer. A single new page in a story that has been slowly writing itself for over 60 years. By the early 2030s, scientists expect to have gathered years of repeated atmospheric readings on dozens of the most promising planets, turning today's faint, disputed signals into something either confirmed with real confidence or ruled out entirely, closing that chapter so a new one can open somewhere else. Somewhere out past Neptune, Voyager 1 is still moving outward tonight, carrying its golden message towards stars it will never actually reach. A quiet reminder that this search has always been a two-way conversation, us listening outward, and us, in our own small way, still speaking first. And somewhere closer to home, right now, a telescope in orbit is holding still, gathering starlight one photon at a time from a planet you have never heard of, slowly building toward an answer nobody has yet been allowed to give. Here is the single image worth carrying with you after this video ends. Not a spaceship, not a flying saucer, a faint, flickering line of light on a graph, sitting in a lab computer somewhere on Earth, representing one single molecule in the air of one single planet, 120 light years away, being checked and rechecked by careful people who refuse to get too excited too soon. That line on that graph might mean nothing. Or it might be the very beginning of the biggest sentence humanity has ever been allowed to finish. Bookmark this video now, or save it to a playlist, because as new data comes in from Webb, from Europa Clipper, from every mission mentioned tonight, this story is going to keep updating itself, and you will want a way to find your way back to where it started. Because whatever the next NASA announcement actually turns out to say, quiet or dramatic, confirmed or still uncertain, one thing already feels true. We are no longer just asking whether we are alone in this galaxy. We are, for the first time in human history, actually building the tools patient enough and precise enough to finally start answering it.